So look at this problem. This problem states that a relation is given in the set 1 to 3, and the relation is given by 1 on 2 2 3 3 1 2 2 3, and we have to show that it is reflexive but neither symmetry nor transitive. Okay, so to understand this problem, first we have to understand what's a relation. Okay, so before understanding relation, we should have a good knowledge on what is Cartesian product. So let us consider a set A, and this set A is given by, for example, 1 2 3. Then what will be the Cartesian product? That is A cross A. So this A cross A is given by this 1 comma 1, 1 comma 2, 1 comma 3, this 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2, and 3 comma 3. So this is the Cartesian product, A cross A. Now what is the relation? A relation will contain some element in the A cross A. It may contain all the element, or may contain some element, or may not contain any element at all if it's null. Okay, so you can see that in the relation R 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, and 2 comma 3. So all the elements are not given. However, some element 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, and 2 comma 3. These elements are given. So this is a relation R. Okay. Now what we have to show is this relation R is reflexive. Now what's a reflexive relation? Now you can easily see that the element of the relation is something in the form of A comma B, isn't it? Something in the form of A comma B. So a relation is normally written as A comma B, but there is a relationship between A and B. Let us consider a relation. For example, A is equal to B plus 1. This is an example only. So the thing is, in the element of A cross A, the form A comma B are available, and there might be a relationship between that A and B. So if there is a relationship, then we say that A is related to B. So now we understand relationship. One thing, don't forget that in a relation, it's not necessary that all element of A cross A must be present. Okay. Now we have to show that it's a reflexive. So what's a reflexive relation? So for a reflexive relation, for a reflexive relation, what we know is that A comma A, this must be present in the relation, okay, for all A belongs to this set, original set. This is the reflexive relation. And what is the symmetric relationship? For symmetric relationship, for symmetric relation, the thing is, if A comma B belongs to R, then B comma A also should belongs to R. For all AB, that must belongs to the original set. Okay? Now you see, in the original set, 1, 2, 3 were there, and the set was 1, 2, 3, it was given. Now you see, on comma 1, as per reflexive relationship, this same thing, A comma A, that means on comma 1, 2 comma 2, 3 comma 3. If 1 is available in this set, 1 is available in this set, 1 comma 1 is available in the relationship. Similarly, 2 comma 2 is also available in the relationship. 3 comma 3 is also available in the relationship. That is A comma A. For all A belongs to the set. That is on to 3 belongs to the set. So if on to 3 belongs to the set, then on comma 1, 2 comma 2 and 3 comma 3 also belongs to the relation. Therefore, it is a reflexive relation. Okay. Now, whether it is symmetric or not, that we have to see. Now you see, we know that if on comma 2 is present in the set, then 2 comma on should also be present in the set, not in the set, in the relation. If on comma 2 is present in the relation, then 2 comma on also should be present in the relation. If A comma B is present, then B comma A should also be present. You see, on comma 2 is present here, on comma 2 is present here, but 2 comma is not present here, isn't it? Therefore, it's not a symmetric relation. Now, one more thing is pending, which is called transitive relation. Transitive relation. Okay, so it's not a transitive relation that we have to see. So the definition of transitive relation is, if A comma B belongs to the relation, A comma B belongs to the relation, and B comma C belongs to the relation, then A comma C must belongs to the relation, where this A, B, C must belongs to the original set. So this is the definition of transitive relation. So if on comma 2 is present and 2 comma 3 is present, then on comma 3 must be present, isn't it? So you see, here 1 comma 2, here in the problem, if you see 1 comma 2 is present here, 2 comma 3 is also present here. So if it is transitive, then 1 comma 3 must be present, but 1 comma 3 is not present here. Therefore, it is not transitive. Okay, so we can see that it's reflexive. However, it is not symmetric as well as it is not transitive also. Okay. Now, one more thing I want to mention here is, if a relation is reflexive, symmetric and transitive, then it's called equivalence relation. So it's reflexive relation, but it's neither symmetric nor transitive. Therefore, it is not equivalence also. So we can write it is not equivalence relation also. Equivalence are also. So hope you have understood the concept